Let's practice different types of reactions. So we have learned 4 types of reactions: combination, decomposition. Combination is where 2 elements combine to form a compound. Decomposition is where a compound will decompose into its constituent elements. We've learned about 2 types of replacement reactions. So we have learned about single replacement, where if a metal is more reactive than the metal that is with a compound, it will replace it. So for example, we have A that goes with B and C. Well, this is your metal, and that's your non-metal. So when A is more reactive than B, B will go away. It will be kicked off essentially, and A will form with C. And then we also know double replacement, which is when you have 2 compounds and the metal and non-metal switch. So AB plus CD. Metal, non-metal, metal, non-metal. So here the metal will go with the non-metal. It will replace this. And then this metal will go with this non-metal. Then one more, combustion, which is where you have a compound that is containing carbon, hydrogen, and oxygen that forms with O2 always to form carbon dioxide and water. So those are our types of reactions. So let's practice. Classify the following reaction as a combination, decomposition, single replacement, double replacement, or combustion. So let's look at this first one. Let's name it as practice, this compound right here, aluminum and oxygen. So this is ionic. Aluminum is not a transition metal, so this would be called aluminum oxide. We have this aluminum oxide that broke apart into aluminum and oxygen. So this is a decomposition reaction. Next one. Bromine. Then we have this compound right here. Let's name it as well. We have a metal and a non-metal. The metal is not transition, so barium iodide. This forms BaBr2. This is barium bromide, an iodide gas. So this bromine replaced the iodine. So this time it was a non-metal replacement rather than a metal replacement, which can also happen. So this is a single replacement reaction. Next one. We have ethane, oxygen, carbon dioxide, and water. This is a carbon-containing compound that forms with oxygen to form carbon dioxide and water. This is combustion. Next one, let's name all of these. Barium and chlorine, that's an ionic compound. This is barium chloride. Then we have KCO3. This is a polyatomic ion. This is called potassium. And the polyatomic ion for CO3 is carbonate. Then we have barium carbonate and water. When it's an ionic compound, you name the metal and the non-metal. If it's a transition metal, you have the Roman numeral for the charge. If it's just a metal, you just write the name of the metal. Now, in the first couple, we only had a non-metal, so we had the "ide" ending. Now, in this last one here, we have a polyatomic ion, so the ending changes. Now, let's figure out what type of reaction this is. I have barium and chlorine, potassium and carbonate. I see on the other side that the barium went to the carbonate, so it replaced potassium, and potassium went with the chlorine, which tells you that this was wrong. This should have been KCl. So potassium chloride. So this is a double replacement. When you see reactions and they form products and all of a sudden you see that one of the products is wrong, then you have to make sure that you fix it. So for example, H2O was not possible from here because we already determined barium and carbonate came together, replacing the potassium. So the potassium has to replace the chlorine, forming potassium chloride. And those are all the reactions.